Welcome to this episode of the Structural Engineering Channel, a podcast focused on helping structural engineering professionals stay up to date in technical trends in the field and to help them in their careers and lives. In this episode, Rachel and I will be talking with Jarrad Morris, Senior Project Manager at Triton Construction Company, about key structural engineering topics like quality control, stack effect in buildings, managing building movement, and reducing noise and vibration. I'm your co-host, Matt Picardle.
And I'm your co-host, Rachel Holland. Now let's jump into our conversation of the week.
All right. Hey, Jarrad.
Hi.
Thanks for joining us. And could you tell us a little bit about your career journey and what led you to have a specialty in structural engineering?
Okay. Yeah, it's been a long process, a lot of stops on the way. But so I started at Pratt Institute, got my bachelor's in architecture. And last year, we had a career fair. There was about 50 some odd design firms and 2 construction management. I went through, didn't really see anything that was interesting on the architecture side, but the CM that I saw had done some work at the Metropolitan Museum of Art. And working on the American wing, I was very intrigued. So they said, hey, come by, check it out. We'll walk you around. And so I went there and saw everything. Very interesting stuff. I definitely didn't have any understanding of how things were put together. I was, an architect by training at that point, but I had never known how to put things together, and I wanted to get that experience. And so I thought, hey, let me just do this for a couple of years, and maybe I'll go back. So I went into the CM world, worked on a couple projects as a superintendent and an assistant PM, and then probably about two years into it, I started getting really interested in structures and bridges and that kind of stuff. So I went to get my master's in engineering at Polytech, where it's changed. They changed their name to NYU Tandon School of Engineering, and went through that process, finished with my master's. And then obviously during my journey through the master's, I was also working full-time as a CM. I had moved on from the location I was at previously and doing some ground up work at that time. So a lot of 40-story buildings, cast in place concrete, very interesting stuff. But I did not have hands-on engineering experience at that point. So when I tried to sit for the exam, I got the letter back saying, nope, can't sit. You have to work for an engineer. So I had the opportunity to team up and work with WSP for a couple of years, doing shop drawing review, column design, slab design. And I finally had my hours to sit for the exam, licensed engineer. And then I was like, oh, I had my bachelor's in architecture. Let me just finish this up. So went back and applied for the test for that, sat for 6 exams, and now I'm an architect as well. So, I've done a lot of ground up, rental, multifamily rentals, high-end luxury condos. I worked on some of the biggest projects out there, 1 Manhattan Square or 250 South Street, Central Park Tower, Brooklyn Point, some of these massive buildings in the city. So I'm all over the place.
Yeah,
I love that.
Yeah, I wanted to follow because it seems like you're pretty well-rounded. You were educated in architecture, you got your license, then you went into construction to learn all the construction techniques. So you're very in tune with how things are built. But then you also have education in structural engineering. So I feel that would be very valuable.
It definitely
helps you.
Yeah. And actually, one more thing I totally forgot about was I'm actually a licensed New York City superintendent. So I do have the license for
Yeah, you're very well-rounded. And I think the other thing that's really cool just for our listeners to be reminded of is we always think things are linear, you know, your career is going to go in a linear fashion. And it's just, there's so many examples, but you're another example of how it just kind of can
it's
go in different directions.
Yeah, it's definitely evolved.
Yeah. What about, Jarrad, how has the concept of quality control evolved in structural engineering? And what do you think are the current best practices for that?
Well, so at least in my experience, starting out in the field, learning how things were put together, I got to understand, all these details, I guess you would call it like the industry standards for how, framing a wall or putting up a ceiling. But it wasn't until I really started experiencing the issues and defects after, either, during the TCO process or, during occupancy, finding issues with creaking or leaks or stuff like that, where I really started getting really involved and really interested in fixing the problems, during construction and even pre-construction during the design phase. So quality control is a really huge component of my experience and my career so far. And I'm very invested in making sure I'm doing everything I can to do to create a quality product. So we, over the years, I've kind of developed, along with a lot of colleagues, a really strong lessons learned protocol during the design phase and construction, and obviously turnover, but also more like a checklist. And every building is a little different. So the checklist is a boilerplate, and we kind of modify it as we go. And depending on, the systems, curtain wall versus window wall, we'll adjust the quality control, things that we'll check. And it just makes sure that, one, there's no issues, right? So it's not, window guy came out today, can't install the window because this is not done. So it's more of a proactive, approach to getting things finished.
Yeah, I think like that's another thing. Like, I mean, obviously it comes into play, the quality aspect of everything comes into play with these big projects and stuff like that. But I feel like just in our profession, just overall, like, we all are just so, we're so responsible for like the, just that built environment and like the end product. So the quality throughout the whole thing is just so significant.
And over the years, when I started out, at least when I started getting into the high rise portion, almost everything was a rat race or a fire drill. We gotta get this embed in place. Well, we don't have a shop drawing. Oh man, let's get the shop drawing approved, and let's get this on site tomorrow. And now it's more of how do we make sure that we are planning ahead, doing the right thing, making sure the site is ready for it, it's prepared. We have access lines ready to go. A lot of these things that people end up missing or overseeing. Just because the nature of the business, I like to focus on those details and making sure that we are in the right place. We're proactive, and so there's less mistakes.
Yeah, and especially with all of the different disciplines, I know there's enough QC going on in the structural engineering offices, but out on site where there's so many different disciplines, so many different. If anyone's ever looked at a construction schedule.
Oh yeah,
for our listeners, it's intense with all the trades that are going in and what needs to be. I'm not envious of that at all.
Right.
But yeah, that just shows how much more important the QC control is because you've mentioned everything's hot, everything's a rat race. They need it tomorrow, and we can work like that. But it's I think it's safer for everybody once we know everything's in control, and I think it takes people like you that. Take the QC seriously and they're very detail oriented.
Yeah.
And I wanted to jump into the stack effect for our listeners that don't know about that too. Could you explain that and what the significance of that is?
Right. So stack effect or air buoyancy, most people know hot air rises, right? And if you have a very tall building, almost like a chimney, right? The hot air from the bottom wants to rise, and then the air below gets displaced, right? And then wants to fill in with something else. So as the air rises, more air wants to rush in to fill in that void. And for a chimney, it works great. For tall buildings, not so much. And what ends up happening is the typical shafts, right? Your stairwells, your elevator shafts become these chimneys. And way back when, with the old code, there was a requirement of a 1/3, 2/3 opening at the top of the elevator shafts, which was great for, the removal of smoke if there was any kind of smoking condition in the shaft. However, it's horrific for stack effect, and it just allows for the movement of air. Many people that obviously live in these tall buildings or even build these tall buildings totally understand the issues, even building it. It's horrible to, get people up and down in elevators when the space is wide open on the ground floor. Usually the ground floor is left open at the very end because that's where everybody's mobilizing, logistics, loading docks. That's usually the last place to finish and enclose. And that's what introduces all the cool air into space. But because of that airflow, you will have issues with doors closing, opening, elevators not working, shutting down because of the safety factors. And then mechanicals. If you have air getting pushed into a space, the mechanical, pressures and stack effects. So the mechanical spaces usually have a static friction that they have to deal with. And if you start to introduce an airflow into a space which is not designed for it, you can start damaging the units. So stack effect is huge, and it can definitely affect everything in the building.
That's really interesting. I've never in my previous consulting experience, I never worked on high rises. So totally new information for me. And it sounds like it's challenging. So like, how do you deal with them? And like, where do you come into play with dealing with it? Is there like innovative solutions, or like, what do you do?
So this is kind of where my background, it really starts to peak. So I do have, I would say better than a basic understanding of mechanicals. I did a lot of mechanical coordination over the years. So I'm not saying I'm a mechanical engineer, but I do have a very good understanding of how the systems work, how the systems operate. And so when I get into a job, it's usually over 40 stories where you start seeing the true effects of the stack effect. It's a different mentality than I guess a lot of people that are very specialized and focused, like mechanical guys, just understand, most of the time they just understand their mechanical systems. Well, versus architecture, I just know my doors and frames and hardware. And then obviously structural, I'm only concerned or only know what the loads imposed on the building. So me being able to see it from different lenses and different hats, the idea of the movement of air, if you can just break it down to, stopping that movement, right? If the elevator shaft is a shaft, right? There's nothing stopping it. I've dealt with projects where we tried, working with RWDI, who is, world renowned on these towers and wind movement and stuff, working with them, trying to work at a program. We've tried to temper the shafts. We, plugged in a couple openings every mechanical floor to condition the air so that the temperature gradient basically stays where it is or where it should be, let's say on a normal summer day or something like that, trying to make sure that there's no temperature difference from the top to the bottom, and therefore not introducing any buoyancy, right? But I would take it even further, and I would just completely isolate the shaft. So what I've seen is elevators are not airtight. I've worked on a bunch of projects with a bunch of different elevator guys. There are weather seal gaskets and such like that. They're not fit, and most of the time they get damaged. They need to be replaced all the time. In my mind, the elevator and the corridor are one volume. So using that as an idea, make sure that the air is neither negative or positive. So there's no pressure differences. So the air has nowhere to go. If you can compartmentalize these volumes and keep them separate from anything from the outside or inside, you can mitigate the air flow, which is something that a lot of people, I think what that process is a little different than a lot of people understanding the process, but it has helped me in the past on resolving the movement of air. So a lot of times I'll focus on the stairwells, making sure those gaskets are perfectly sealed. They have a drum seal, they have a gasket around the frame. There's, a lot of people like to condition the air in the stairwells. Like at the very top, they'll put a heater in. Sometimes they put it in the very bottom. I would say you don't put anything in. And if you do, it's only at the top, just to temper the air that you might be, when you open the door. It's completely tempered. Because if you put that heat in the bottom, it's going to want to continue to rise in the stairwell. And so
Yeah, I was just going to say, when you said you would put the heater in the top, trying to work through how that works. Like if the hot air wants to rise, but you already have the hot air up there,
it just basically
does that make it not go up?
It just doesn't need to go up. It doesn't go out anywhere. If anything, it just can kind of like fill that volume at the very top. And if anything, if there's more of it, it'll just start to migrate down to fill in the space below. But it's not.
So it'll kind of like counter
Right.
what's naturally happening?
Yeah.
Okay.
And another thing is, which a lot of people don't think about, is the reverse happens also. So stack effect, obviously in the wintertime, very huge amount of air rushing up, cold air coming in from the entryways going up. But in the summertime, it's the reverse. So it wants to go down, then come out. And another thing that happens, which, in a multifamily house or building, you have people opening up windows. I'm cooking, so I want to open up a window because, getting the air out. That is a huge no-no. And that is a huge component and contributor to a lot of the stack effects in a lot of buildings. So if you're in a multifamily dwelling, keep your windows closed, as much as possible.
So is this it seems like the stacking effect, it's not just during construction, it's when the building's built too, right?
Oh, yeah.
Because of the shaft.
Yeah. No, definitely. It's definitely, you'll see it in construction, but obviously everything is still open. Almost everything is still not completely tightened. Gaskets aren't installed yet, so there's a lot of airflow. But when it's occupied, that's really when you see the real problems of elevators shutting down, not being used, doors being impossible.
And Jarrad, how tall, like how many stories does it need to be before this really becomes a consideration?
I've seen it. It's less of a huge burden, but I've seen it on 40 stories. But obviously, the taller you get, the more of an effect it is, and more of an issue.
So you're saying like 40-story multifamily, then you should keep your windows closed?
Well, it's going to be anywhere that you have a temperature differential, anywhere that introduces that difference, from the bottom to the top, just like a chimney, right? So a chimney could be 10 feet tall, could be 1,000 feet tall, but the taller the building, the more that effect is detrimental to the building, the systems, and occupants.
Okay, so something that's like 10 stories doesn't typically have this?
It's definitely not as noticeable. You probably won't even realize it, but it all happens in any size building. It's just less of a burden.
Okay.
Yeah.
Okay.
So,
thank you.
Like what we were saying before, 40 stories is probably where you're going to be more, thinking about those type of issues and trying to prevent them.
Yeah, you're taking me back to my thermodynamics classes. Hot, cold. Yeah, that's really interesting because, I haven't really thought about that. But it's one of those things there, a lot of the lessons learned, right? After it's built, and then you'll get customer complaints or issues once the building's in full operation. It's like, what is this happening? Oh, this thing that no one's really thought about because everyone's so specialized.
Right.
So that's really interesting.
But it's also interesting. I've never lived in like a condo tower, that's over 40 stories, but like just personally, like in my living space, like I want to be able to open a window. So like, can you really tell a resident, like, or can you make those windows not able to even be opened? Like, is that even allowed?
Obviously, new codes require ventilation. So there's light and air requirements for the new buildings. Way back when, let's say, 1920s, with the the tenement housing where there wasn't enough light or air, that wouldn't have been an issue. But nowadays, when you have these big, tall, glass structures, windows are 3 foot by 6 foot. It's a massive pane of glass that, when open, it's providing that light and air, but it's also a huge pathway to get out. There really isn't anything saying that you can't open your window. It's just, you will have drop seals and gaskets at your entry doors also, right? So that's going to help isolate your apartment from the corridor. And on that, your apartment wants to be more positively pressurized, right? So you want to have a positive pressure in your apartment versus the corridor, because you don't want anything like, let's just say you're smoking in your apartment. You don't want that smoke to come out of your apartment and into another apartment. So you always want to keep every apartment high, positive pressure, and then the corridor negative pressure to minimize that movement of air. But because of that, now that if you open your window, you're going to change that flow, right? And now you can make your apartment negative and forcing air from other people's apartments into yours. Also, like we talked about, it affects the ventilation. So you will have ventilation in your kitchen, right? You'll have your ventilation in your bathroom. Typically, it's monitored, or there's either a VFD or a car damper that's regulating the flow of air. So if you have a huge gust of air that blows through, you could mess with the car damper. It can jam it up. Could definitely mess with the dynamics of the building systems.
And yeah, that was interesting in terms of all the things that go into that. It's like, what do you call it? Serviceability things that.
Yeah.
But basically, if the elevator's not working, you can blame someone for cracking open their window.
Right. Yeah.
Some other things that I wanted to get into that may not be as observable to people that haven't really delved into it. What about building movement? I know that's a critical factor. Could you jump into that one and explain to our listeners how that goes into structures?
Yeah. So obviously, the taller the building, the larger the movement. Because of my experience in some of these really tall ones, the buildings move, and a lot of people don't want to hear about that because it's a little disconcerting to know that your building is moving a couple feet either direction. But the buildings move. It's like a living thing, and it needs to move. If you try to restrict it, it will crack. It could break. Panes of glass can start to crack if there's enough torsion. But that's the other part. Buildings move, but they don't move as simple and as straightforward as you want it to move, right? Most of the time, they're going to get a wind gust in a direction that may be not perpendicular to a facade. And so it's going to want to twist, and there's torsion depending on the shape, right? If it's an asymmetrical shape, it's going to want to twist in a certain way, based on the center of mass. There are a lot of buildings in the city that move and rotate. Some are worse than others. Some have slosh tanks and mass dampers at the top to minimize the feeling of that movement. You still have the movement, but it's less of a feeling, when you reduce the period, when the building moves one side back to the other, that's your period. If you can reduce that so it's less of a realized feeling, right? But if you try to stiffen it up, and some designers think stiffer the better, right? You actually will start to introduce more of a vibration, and you really don't want to have that. You want to let the building move. You want to let it sort of flow with the wind. When you don't, and you try to restrict it, and a lot of times it's more about the interior partitions and the exterior facade and structure. When you try to engage both of them and have a rigid connection between both, you will have cracking. You will have noises. Sometimes it's really audible. Sometimes it's not. I had a teacher at Polytech who did an analysis on the old Trade Center towers and how they moved. And he said that the people that worked at the very top, they would get sick. They would have like a seasickness as it was moving too much. The creaking of the sheetrock against the ceiling would be audible. People would hear that. So it's the same thing in all these buildings. But obviously now we have a little bit more limitation on them than before.
So you mentioned like wind. That's the most obvious one. Are there other causes for building movement? And then like my other question, we had a guest recently that dealt with dampers at the top of buildings, but is that typically what you'll do, is like a slosh damper or the
mass damper?
The mass damper, is that, or do you have other ways of dealing with it?
So those are the key types. I'm sure there's some others out there that minimize the movement, but slosh tanks are typically at the top of residential towers. Very few buildings like Central Park Tower and Taipei 101 have the mass damper, which is just a massive steel, maybe even encased or not encased, but filled with concrete. Just provide that extra mass to counterbalance the wind movement. It's usually water in a tank, almost like a pool that will mitigate that move. That's typical of very tall buildings, usually residential. I don't know of any commercial building that has one. Usually they don't do that. It's not, worth it, I guess.
Yeah, and what you mentioned noise and vibration as well, especially with maybe the non-structural elements, just scraping and at each other. But yeah, could you go into that? What are the lessons learned that you've used to mitigate those types of maybe non-structural issues, but super annoying if you live there?
Yeah. So a lot of these buildings, these super talls and even like 40 stories above, the suggested approach is to either have a slotted track or a vinyl line track in your partition. So that thing will move with your slab above, while as the stud below just will stay where it is. And the movement from live load will just keep going. And then all this, obviously, you can move side to side. Now, there's nothing really helping it with the rotation. So when you have your interstory shifts, right, when one floor wants to move past another or wants to twist, there's really nothing that's really good at this point that I've seen that will limit any of that movement. What usually happens is at corners or intersections of walls, that's when you're going to have that possible torsion. But what I've seen is if you can just essentially disengage all the partitions, everything from that floor, and you could probably do it either way, but the best is disengage your partitions, mount them to the floor, right? Have them almost freestanding and disengage it from the slab above so that when they do move in different directions, they're not restricted. Because when it's restricted, that's when you start hearing the noises and seeing the cracks. So you always want to restrict it from shear walls, columns, any of the main structure. And then obviously the same thing with your window wall. Your window wall is or curtain wall or any facade element, it's going to flex with the wind pressure, right? And some facades like brick will have less of a deflection than glass. But, depending on the floor-to-floor heights, it could be a half inch deflection at the midpoint. So you want to allow that to move. You want to make sure that there is a gasket so that it's sealed, but also, allows to expand and contract. And then obviously you have to make sure that it's all fire stopped and sealed between floors and between the demising.
Super interesting how that all comes into play.
Yeah.
What about in terms of emerging technologies and methodologies? Like, are there any that you're excited about or super excited about in structural engineering? And then, obviously related to this, like quality control, building dynamics, and things that you've really have a lot of experience.
Yeah. Well, on the structural side, a lot of these BIM tools are great, right? Analyzing and visualizing the space. But one of the things for the quality control side of things is what I've been using now, OpenSpace, which is basically a camera tour of the building, right? So you'll have a camera. Some people either mount it on their hard hat and walk around, or they can hold it. But the camera takes pictures of everything, and you do it at every stage of the project. So if you're pouring concrete, you do it, when you form the deck, when it's poured, when you're laying out your walls. And then obviously the critical thing for most people is when you're piping all your risers and then you close up that wall. Now you want to mount a cabinet, but you don't remember where that pipe was. You can go back into an OpenSpace and you can basically go through the layers of the progress of the job. And so you can find out where, there's a water line there, or there's a gas line there. I can't screw into that. That's been a huge advancement, at least for me on the construction side, to make sure that we're doing the right thing, right? We can track the progress, but also we can make sure that we avoid any issues in the future.
How does that work? So the open space sounds interesting. So you're saying through each phase, there's a camera that takes photos? And
so I think I've heard of a camera stationary on floors, but that just seems a little costly if you're going to do that on every floor. But no, for what we are doing, we're holding that camera, and it's all recording into the cloud. So all the layers get piled floor by floor, and then we'll go back to our desk. It'll load up into the cloud, and then you can basically download a floor and see all the different layers. But you have to physically walk through the space and walk-in.
What about once you've captured all of that imaging, do you have to like manually go through it, or is it some sort of like a program that will like put it in the right place of your building?
Yes, there's a program. So basically it'll capture, it knows where you are. Before you even start with the running the camera, you'll say, okay, I'm on this floor, I'm starting. And then it'll capture the information and then bring it back to the model. They have.
So like later on, you could be like, I want to look at story 42 on the north side wall where like pipe whatever is,
Yes.
and it'll just find it.
Well, you can go to that floor and then you'll just scroll through the floor plan to get there. But yeah, we input a 3D model of the building so they know how many floors there are, and then we'll just tell them, hey, I'm on this floor at stair C, and then that's when the camera starts. It'll triangulate itself and know where it is.
That's awesome.
Yeah.
What about
Love that.
I don't know if you've worked with post-tension tendons before. Does it work for that?
I mean, I'm sure it could. Yeah, I'd never used post-tensioning. I know that's a huge thing in Florida. I just don't think we have the personnel knowledgeable enough to do it here yet, but maybe soon. No, I mean, I understand the process, and I think it would be great for that.
That's interesting.
Yeah.
Jarrad, last question. I know you have a lot of experience in all these different disciplines, but did you have any advice for structural engineers, maybe architects, maybe even engineers that want to get into construction? Do you have anything for them to be successful and have an impact in their careers in this field?
Well, I guess for each one, right? So for architects, if you really love architecture, stay with it. There's a lot of us that are going away from it, and we need some strong architects. Yeah, I know it's usually hard. I remember when I was at Pratt, we had a bunch of classes where they informed us, you will not make a lot of money. Are you guys still interested in going ahead? They basically told us all of the the bad stuff, but hopefully I do still have a lot of friends in architecture, and we need some more good, strong architects. So definitely find a practice that's good practice that you can learn a lot. Find a mentor, and make sure you learn as much as you can. Ask a lot of questions. Structural engineers, luckily I didn't have to do it for that long, but when I was in the office designing, it was grim. Everybody was spending a lot of hours reviewing drawings, spending a lot of hours designing. It didn't look fun. And again, a lot of those people ended up coming out to the CM world and finding more fun on the field or in the field. Again, structural engineers, we need you. We need, if you're interested and you love it, stay with it. We need some strong guys out there that know what they're doing. Again, it's very hard to find firms that have the mentors and have the time to really teach everybody the right things. It is a hard process, especially some people can get pigeonholed in designing bathrooms for architects. Or, for structural engineers, maybe they're stuck only doing column design and slab design. It would be great to go to a company where you can get involved in wind design, maybe foundations, a little bit of everything. And then for the CM world, it's finding a good team to work with. I've been around a few companies now, and as long as they're interested in making sure that the young people are taught well, that have, good mentors on the project that can kind of guide people through the process, it's very helpful. And obviously with the larger projects, they'll be stuck on that project for 3 years. So sometimes it's beneficial to mix and match, do a commercial interior for 4 months and then do a large ground up 40 stories for 2.5, 3 years. I would definitely suggest mixing it up if you can.
Yeah, that's very interesting. I know it's like, I think for all of these professions, at least for architecture and engineering, it was an interesting route that they gave you of, hey, yeah, you're probably not going to get paid a lot, but it's, what do you call it? What you were saying, if that's something that you enjoy and that's something that you're passionate about,
right,
and all the bad things going into it, and if you could say yes to that, then I think that's great, because if it's for you, it's going to be one of the most fulfilling careers that you get a lot out of.
Yeah. I actually,
and I think you touched on it too, like just being open to change.
Yes.
Like if you're not really fulfilled in your current role, position, company, whatever, like it doesn't mean that you shouldn't be an engineer, you shouldn't be an architect. It just means maybe you need to find a different position or a different company or a different team or whatever it may be that is more fulfilling to you. Right. So like kind of don't give up.
Yes, exactly.
I think that's your advice.
But the other thing that, I've noticed, because I went right into the field, I have so much more knowledge and experience that I probably could never have kind of equated to 20 years in college, another 20 years. I would suggest for everybody, and it really should be like a mandate for getting your license, you should find a trade, carpentry, masonry, electricians, find a trade that you find interesting and get on a job and do work for 2 years. Do the work in the field, understand the process, understand the issues, the defects, all these things, so that when you can go back to your architecture or structural engineering firm, you have a better understanding of, oh man, well, this is what they want to do. This is how they're going to approach this. And you can end up, at least for me, I've become a better designer. I have more insight, more understanding. I could put together a set of plans much faster than I would before. Know the issues, resolve those issues ahead of time. I think it's invaluable thing for someone young that has the time, experience, or has the ability, right? They're young enough, they can jump around, they can run upstairs. They should definitely get involved on a job, field work.
Yeah. And even if you don't have I know 2 years is like a long time, right? And that would be amazing if people could do that. But even I know for us, we really encourage our engineers to go out and do field, site visits. Yeah. So I'm sure it's similar for you, Matt, when you're going out to do inspections and things like that. Just being in the field, talking to the contractors, seeing the stuff firsthand and really understanding the challenges, I think it makes you a better designer.
Oh yeah,
better
definitely.
Engineer.
Yeah. And it definitely helps. I wish that was part of our curriculum too. Actually, since I find it weird where for new graduates, for maybe engineering, I know for an architecture, your task is to design something that you don't even know maybe what the material is.
Right.
Okay. So it's kind of working backwards, and I think that can lead to what the contractors what are they doing?
Yes.
There's a disconnect. So I think that would definitely help if that was part of our educational curriculum for
definitely
engineers. Yeah, I could definitely see the benefit in that. But yeah, thanks for the advice, Jarrad. I really appreciate you coming on and sharing your experiences and lessons learned. I definitely learned a couple of things here. So
Me too. Yes. Thanks, Jarrad. I totally appreciate it. It was great to meet you and talk to you.
Yeah, definitely. Thank you. Thank you for inviting me onto the show. This is great. I appreciate it.
I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit thestructuralengineeringchannel.com. There, you will find a summary of the key points discussed in today's episode, as well as the links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.